Okay, here comes a question that is quite tricky. I will show you how to calculate the correct answer, but also how you could argue without doing anything, without doing any calculation. It will go much faster, but it doesn't feel that accurate, but I will try to explain it for you. Let's read the question first here. Two containers, X and Y, are maintained at the same temperature. X has volume 4 cubic meter and Y has volume 6 cubic meter. They both hold an ideal gas. Ideal gas law works then. The pressure in X is 100 Pascal and the pressure in Y is 50 Pascal. The containers are then joined by a tube of negligible volume. What is the final pressure in the container? Well, first you could say like this. 50 Pascal and 100 Pascal. If the volume of these two containers would be the same, and you join them together with a tube, then of course the final pressure would be exact in the middle of these two values. So in the middle of 50 and 100 we have 75. Maybe 75 is an option so that the IB system tries to trick you or see how skeptical you are. So you understand that that is not the case in this situation, since the volume is not the same. Okay, then it says that the pressure in X is 100 and the pressure in Y is 50. And then it says that Y has the bigger volume. Y has the volume 6 cubic meter. Now the container with the biggest volume will most affect the final pressure when you are joining them together. Most volume affects more. Therefore, the final pressure needs to be closer to 50 Pascal, since 50 Pascal is in the container Y. Now 75 is exact in the middle between 50 and 100, but since 6 cubic meter is greater than 4 cubic meter, it will get closer to 50 Pascal. A is the only options where you have a pressure that's closer to 50. Therefore, A is the correct options. Let me calculate it and show you that I can get to 17. You will see it. It's a little bit tricky. Ideal gas. Let's write down the ideal gas law. That's probably how you will start as soon as you see ideal gas. Write it down. And they are asking for the final pressure of in the container. So I will solve for P here. So pressure is nRT over V. Okay, let's see here now. So when you have joined these two containers, the number of molecules will be the number of molecules in container X plus the number of molecules in container Y. Therefore, I could write it as NX plus NY, of course with a parenthesis around it, R times T. And it says that they have the same temperature. If they start with the same temperature, they will end with the same temperature also. Divided with the volume. The volume is the volume of both the container X and Y together because they are joined by a tube. So that will be Vx plus Vy. Okay, now let's see. It's a little bit tricky now. N depends on P, V, and R and T. let me show you. If I solve for n, this equation, then I will get PV over RT. Therefore, instead of nx, I could write it as px times vx over RT. Plus, then comes ny. That is py times vy over RT. Parenthesis, RT. So these RT are the same here. Multiplication. So nx is this, and ny is this part. Divided with vx plus vy. Vx plus vy. And now you see I can use the distributive law and multiply both of these terms with RT. So when I multiply with RT here, I have RT in the denominator and RT in the numerator, so RT will be cancelled away. And then I need to multiply the second term here in the parentheses with RT. RT in the denominator and RT in the numerator. So these are also cancelled out. Therefore, the final pressure will be Px times Vx plus Py times Vy over Vx plus Vy. And P and X is what I do have in the exercises. So let's put in the values and see what we do get. Px was 100 Pascal. 100 multiplied with Vx, that is 4, plus Py, that is 50, times Vy, that is 6, divided with Vx, 4 plus 6. Let's see if I can do it in my head here. So 400 plus 6 times 5 is 30, and a 0 extra, that's 300. So 400 plus 300, that is 700, divided by 10. And since I have the SI units, the answer will be in Pascal. The unit will be in Pascal. And of course, you know that 700 divided by 10 is 70. And that was option A. Therefore, A is the correct answer. A hard one, but you can do it.